Hi everybody. So today we are going to talk about two common sorting algorithms, selection sort and insertion sort. And these algorithms are used so that we can sort an array or an array list so that then later we can use it for binary search, among other things. So the first thing we're going to talk about is selection sort. And so in plain English, what the selection sort does is it visits all the spots in the array from left to right for each spot. And it finds the smallest remaining value that we haven't considered yet from the array. And then it swaps it with the value at the current position. So that is, in the first pass, we find the smallest value. So that means that the very smallest value gets found the first pass of your loop. And then in the second pass, we find the second smallest value and we swap it with the item at index 1. So if we look at this demonstration here, you see 2 was found first. Then 3 was found after that. Notice 5 is the next current smallest, so it was shown to be red. Now 15 is the next current smallest, so it's shown to be in red. Now 26 is the next current smallest until it becomes 19, and then that's the next current smallest. And it just goes on and on from there. So you're finding the very smallest, you're storing that value, and then you are swapping it with whatever the current index that your loop is on. And then it keeps going, and now we're sorted. So here's an example of the code that you would use to complete a sort like selection sort. And there are lots of different variations of the way you would write code for this, but this is just one example, and it's code that you will see on multiple choice questions on the AP test. We would not ask you to write this code on an FRQ, but you do need to understand what it does and be able to answer questions about it. So the way it works is we have a for loop where we have some integer I equals 0, and then it goes through the elements dot length -1. And that's because by the time we get to the last value, it is in sorted order because it has to be, right? The only one left has to be whatever the maximum value is in the array. And also note that this can be used, the same algorithm can be used to sort an array list, right? So we're using an array in this situation, but it really could be either or. And so then we start at some index for the minimum value. So we're going to assume that the first value is our smallest value. Now, it might not be, but we're just going to start by saying, okay, let's just assume the first value is the min value. And so I'm going to set min index equal to I. And then we're going to do another for loop through the same exact list, but now we're going to start at I plus 1. So this is something that you did in your song project recently. And so when we start J at I plus 1, you're just starting at the one right after the one that the position that you're on. And you're checking through all of these elements and you're saying, okay, if elements bracket J is less than elements bracket min index, so if the value at where I am at J is less than the current minimum, then set the current minimum to J. Then after this inner loop finishes, that means that we have found the very minimum index. So now we know what the actual minimum index or what the actual index of the minimum value is because we've checked every single one. And then we go to this if statement. So if I is not equal to the minimum index, so if the one that I'm currently at is not the minimum index, then I want to swap the value at the minimum index with the value that I'm at. And so this code here just does the swapping. So we temporarily set a value equal to elements bracket I, then we change elements bracket I to the minimum, and then we set where we had the minimum. Originally, we set it to that temp, which was we stored where elements bracket I was. So let's look at this in practice. So say we have an array and it has all these values, and here are the index values below it. And so what's happening first is that we dive into this first loop. We start at I is equal to 0. Then we set our minimum index to 0. And now we know that j is going to be equal to I plus 1, so j starts at 1. Now we're going to check. We're going to say, okay, is the elements bracket j, so elements bracket j is elements bracket 1, so is 44 less than elements bracket min index, that's elements bracket 0. Is it? No, because elements bracket 0 is 3. Okay, great. So now we continue on with our loop. So now this inner loop increments. So now instead of minimum index doesn't change, and so j increments, and j is now 2. And so now I'm going to check elements bracket 2. Elements bracket 2 is 38. Is 38 less than where my minimum index is, which is still 0? No. So I continue on, right? So I don't do anything. I just continue on to the next value. So now I'm going to say, okay, j is equal to 3. And so when j is equal to 3, then I'm looking at 5. Is 5 less than the minimum index value? No, because 5 is not less than 3. And then we go and continue, and now j is 4, and at 4, is 47 less than 3? No. Then it goes up to 5. Is 15 less than 3? No. J goes up to 6. Is 36 less than 3? No. Then we go up to 7. Is 26 less than 3? No. Up to 8. 27 less than 3? No. Then we go up to 9. At index 9, we find a 2. So now we say, okay, elements bracket j is 2. Is that less than elements bracket 0? It is. So what we're going to do now is we're going to say, okay, we're going to set our minimum index to the value of j. So now minimum index gets changed to 9. And now I just continue on with the loop. So now I'm going to go, now j is going to be 10. Is the value at 10 less than my current minimum? So right now, this is my current minimum. So I know my current minimum index is 9, and I'm looking at 46. Is 46 less than 2? No. So then I move on. I go to 11. Is 4 less than 2? No. Go to 12. Is 19 less than 2? No. 13, 15, no. 14, 48, no. So the for loop finishes, and then after that inner loop is done, we go into this if statement. The if statement says if I is not equal to the minimum index. So the minimum index is 9, and I is still 0, because we were still on that very first pass. And so they're not equal, right? They're not equal at all. So what do? I swap. So this code here does the swapping. And when I say I swap, what that means is I take the 2, I cut it out, I store it, I replace it here, and then I take the 3 and I put it in the spot where the 2 was. And now I'm going to continue with my loop. So now finally, I finally increments to 1. My minimum index gets set to I, so that means minimum index is going to be 1, and j is going to be I plus 1, so that's 2. So now I'm going to look at this value 2. And we're assuming that my minimum index is 1. Is 38 less than 44? It is. So right away, I'm going to reset my minimum index to 2. Is 5 less than 38? Yes. So I'm going to reset my minimum index to 3. I found another minimum. This one wouldn't, this one wouldn't, this one wouldn't, this one wouldn't, this one wouldn't. I get to 3. Great. 3 is less than all of those other things. So I'm going to reset my minimum index to 9. And now I'm going to do the whole switch again, and this whole thing just gets sorted very slowly, or I mean, if a computer is doing it, much faster than we just did. And that is selection sort. So one note about selection sort is that there are various variations of selection sort, but they're all ultimately the same algorithm. And unfortunately, its best, worst, and average case performance are always about the same and pretty poor. And that's because it always visits every item in your array to check, is this smaller, is this smaller, is this smaller, is this smaller, and it just continues. So selection sort is not something that you will see in the real world being used right now, but it is an algorithm that is assessed on the AP test, and it's one that's pretty straightforward to understand. Insertion sort is an algorithm that you will actually see used in the real world. A lot of times it's in a combination of other fancier things, but this is more efficient than selection sort. And so the way insertion sort works is you're assuming that the leftmost value is, or assume that the leftmost value is in order by itself. So consider the rest of the values one at a time. For each value, swap it with its left neighbor repeatedly until it is in the correct sorted position. So think of this as like you're sorting a deck of cards or like a hand of cards. If you open them up, right, and you look, you'll look at the first two and say, are these in the right order? If not, then you switch them. The next two, are these in the right order? If not, then you switch them. So let's go through it here. So we see, okay, our 40, I need to kind of talk about this. We need to play this a little bit slower. Okay, so if I look at the next one, 47 and 26 were not in the right order. So they swap and they keep swapping until 26 was at the right location. 2, it'll swap with 47, then 44, then 38, then 36, then so it'll keep swapping until it gets to the right position, but it only looks at the one right next to it. So the 4 will continue swapping, 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 swapping until you get all the way down to the bottom. But again, you're only looking at one at a time, so you're only incrementing up one at a time as you go through the list. You're not going through the entire list from the very beginning over and over again. And yeah. Okay, so let's look at the code. So for the code, this one uses a for loop and then inside of that a while loop. And so what it does is it starts at I is equal to 1, and that's because in our while loop we're comparing 1 and the one before it. So I want to look at my value for j and my value for j minus 1. So what I do is I go through, I start at 1, I set j equal to what my I value is, and then I say, okay, while j is greater than 0, so while I'm not at the end or at the beginning of my list, I want to continue to check to see if the one right next to it, so if the one to the left of j is bigger, because if the one to the left of j is bigger than the one at j, then I want to swap them. And so let's go through this code using actual values because I think that helps. So in here we have for int I equals 1, I is less than array.length, and so I and j both start at 1 here because I is equal to j, or j is equal to I. And so I say while j is greater than 0, Okay, it is. And array bracket J, which is array bracket 1, is less than array bracket J minus 1. So that's array bracket 0. So while 44 is less than 3. Is 44 less than 3? No, it's not. So right away, we spill out of this while loop, nothing happens, and then we increment. So now instead of 1, I is going to be 2, which means that j is going to be 2. And so now I look at 38, and I say, okay, is 38, which is array bracket j, is it less than the one before it? If it's less than the one before it, then I want to do swapping. So these 3 lines of code does the swapping. So it swaps because it says, okay, well, 38 is less than, so I'm going to swap by cutting this, putting this here, and that's literally what that swapping algorithm does in those 3 lines of code. And so I swap. Then I do j minus minus. So now j is back to 1. And so now I go back through this while loop. Is 1 greater than 0? Yes. Is array bracket 1 less than array bracket 0? No. So then I spill out of the loop. Great. So now I go back into this loop. I is going to be 3, which means j is going to be 3. And since j is 3, I have the value of 5. So now I'm going to say, okay, j is greater than 0, so 3 is greater than 0. Is the value of the array at index 3, which is 5, less than the value before it? So that's the value before it. Is it less than the value before it? It is. So because it's less than the value before it, I'm going to swap. So that means that swapping happened. And because I swapped, now I want to keep going down because I'm not done looping through this yet. I haven't finished checking 5 with everything else to the left of it. So now I'm going to j minus minus, make j 2, go back through this loop. 2 is still greater than 0, so I'm going to keep going. Is the value at index 2 less than the one before it? It is. So I'm now going to swap again. So now I can swap here, take the 38, move it just right where the next one is. And so now I have 5 and I have 38 and my j is 2 and I did the swapping. So now I can do j is equal to 1. And so when j is equal to 1, it's still greater than 0. And at array bracket 1, 5, is 5 less than the one before it? No. So now, because this while loop doesn't execute, I can spill out of this while loop, go back to the for loop. The for loop then increments to 4. J now becomes 4. And I do this whole thing over and over and over again, and this video is getting really long, so I am going to stop talking. But that's how you would trace through the code. And we are going to talk a lot more about this on Monday or Tuesday or whenever I see you next. And obviously we're not done sorting this list, but we have sorted it up to index 3 and even index 4 if we had actually gone that far. And that's it.